Yes, welcome everyone. Welcome everyone. Let me share my screen in order we should start for the lecture. So, in order to create bar bending schedule, as we are here, most of us are engineers and they know what they are doing. Some are even registered engineers. So we will just have a little demonstrations of what our BBS template will do. That is the aim of the lecture. Not we are going to do bar bending schedule on how to estimate the quantity of the reinforcement, but a little demonstration, we are going to show how to just create a simple for only one element and also to show how we can use such our BBS version 2.0 in Excel. So what I am going to do now, I'm just going to launch my Microsoft Excel. When I launch my Microsoft Excel, as we released a video last week lecture, we demonstrate how to install such a file in your Excel. So when I click here, when I opened my Microsoft Excel, I will try to locate my BBS template, and I will not see it automatically here because you will see the plugin at the ribbon of the software. So what I am going to do again, I'm going to install my template inside of Excel. I'm going to come to the developer tab, click on Excel add-ins. You will see the file here automatically. So if you don't have developer tab, you can come into insert. When you click on insert, you will see my add-ins. Click on this drop-down list, come back into manage other add-ins. Then such dialog box will open automatically for you. When it's open this one, you come here into manage Excel add-ins and click on go. Then it will open automatically for you. Then click on OK. So, you can come here into account. When you click on more, click on option, then you can come into add-ins. When you click on add-ins, this is you will see your manage Excel add-ins here and click on go. You will see the BBS version 2.0. Then I will click and just click on OK automatically. Then it will ask me to install such file. So you will see it will generate a serial number for me automatically here. Then I will ask for activation code from S.A.DESIGN console, in which it will send me the activation code, something like this, in order to activate the file. Then it will activate the file for me automatically, and you will see the plugins in Excel automatically. So normally what brings our attention in order to create such add-ins in Excel is that the way some of our engineers are doing in drawing bar shape in Excel, which is tedious, which is laborious. Let us speak as structural engineers. When we say something is laborious, something of time consuming, normally on BS 8110, they bring this word laborious when you are dealing with column design. So those of you who have attended manual design lectures have saw the laborious way of estimating the moment rather than doing software method analysis, since when you are doing your beam analysis in using software or manually. So in order to enhance such activities, our management start thinking of how can we solve this problem in order to be drawing the bar shape in Excel automatically without any waste of much time, or engineers just be taking tools of Excel, drawing this place, drawing here, doing here. That is time consuming automatically. So let me just have a little demonstration of some of the bar shapes that I am going to draw using our add-ins automatically. When I click on bar shape 01, it will draw the bar shape for me automatically. I can drag it, take it any place I like within the Microsoft Excel. If I like another bar shape, I'll go to shape code 11, which is underscore the first one. It will draw the bar shape for me automatically. Or if I come to shape code 21, click on this one, it will draw the bar shapes. When I come into shape code 28, that is the first one, it will draw the bar shape. Normally, some of you will understand which type of bar shape is this one, which is normally on staircase design. When I come into shape code 34, then you will see how it will draw the shape code for us automatically. So normally, uh, when you draw the bar shapes just like this, you can delete them automatically using one feature that we enhance here, that is delete shape. Normally, you can click one by one, click on this one, press delete, click on this one, press delete, but it is what time consuming. If I press Ctrl Z, it will bring that bar shape automatically. So when I click on the delete shape, it will ask me, are you sure you want to delete all the bar shape in the active sheet? I will say yes in order to delete such bar shapes. So, but one thing is that when you use such feature, you can't bring the bar shapes back here unless you use the other manual way that I show. That is the first manual way. So first, let us go to what is bar bending schedule. What is the bar bending schedule table? Bar bending schedule table, it is a table in which it is representing the shape of reinforcement, the cut length, and so on. For example, if we say in advance or in extensive, what is bar bending schedule? It is a document showing the list of structural members, bar mark, type of reinforcement, size of rebar, after size of rebar, number of rebars for each members, cut length, total length, shape, location, spacing, position of all reinforcement in the working drawings. So normally that is the method in which engineers are transferring information from one place to another, or to the engineers or site engineers that are working on site in order to know the quantity of the reinforcement that you are going to use. That is the normal simple way. When you just give a structural drawing just like that without any bar bending schedule, so many engineers or so many contractors, surveyors, and others will find it difficult in order to estimate the quantity of the reinforcement. So in order to estimate the quantity of the reinforcement easily, the bar bending schedule come into account. So without before we go into deep on what we are going to do, let me also introduce you to our future into the software, that is S.A.DESIGN Consult, in order to know much more about our company, what we are doing. When you click about, or when you just keep your mouse here, you will have a normally labeled saying click to show much, click to know much about S.A.DESIGN Consult. When we click, you will see the disclaimer of our company. Then we are not interested here. S.A.DESIGN Consult history also you will view such. When you come into help button, when you click on the help button, you will see the procedure, or normally just the few things on how you are going to operate the add-ins in Excel. That is, we have almost from 1 to 10. We have to be using and so on. Just you can go through them and read. For those who have the add-ins, then you can click on contact us in order to have normally our personal information. Yes, that is our phone numbers and our email address. This email address, it is not even complete. We have at gmail.com. I think it is not put correctly there. So that is kind of the issues in which you will be rectifying and updating the file automatically. So normally, when we said we are going to create bar bending schedule, so what and what did we need to know in order to create such bar bending schedule? Normally, when you are going to create the table of your bar bending schedule, you need to have the serial number, the size, the quantity, the shape, the total length in millimeter, and total length in meter. That is normally the procedure where which softwares are adopting, e.g. like Prota, ETABS, TECLA, and so on when creating bar bending schedule. So normally there is another way in order to highlight much more information when you are creating the table. You will list a list of the element, that is the structural members. That is, you must show the bar mark in order for someone when he's checking to see this so bar mark or this so reinforcement is it has so bar mark, and then he will easily locate it in the structural drawing. Then you must show the number of the element, that is the total number of bars, that is the quantity that I have explained, that is the shape, and then the length, and in some other word, you will even calculate the weight of such reinforcement when you are preparing the table. So let us start preparing the table. Assume I will start from here, then I will have the serial number. When I have the serial number, I will come and say the element. After the element, then I will come and put the bar mark. Then after I put the bar mark, I will come and see the size of the reinforcement. That is size of rebar. And also I will put it here. This size of rebar, let me edit it. Then size of rebar, let me increase the size of the displays. Then after I have the size of the rebar, I will come and say the number of the element, in which, in other words, you can present it as the quantity of such quantity. So after we have the quantity, we will come and show the shape. After the shape, so also after the shape, so many people will draw the shape, including the length of any kind of bent of bars there. We present the shape completely with its length automatically. So if you like, you can add additional columns for showing the labels and then the length of such specific location. So let us work with the shape automatically together with the total size and everything. That is the length and so on. Then we have the length. This length, it is going to be in millimeter. But before such, let me put it in millimeter. But before such, you might come and calculate the weight of such reinforcement, in which I will bring it here. I will say weight, which is in kilogram. After such, I will come, let me increase the size here. I will come and say the total length. That is the total length in meters. When you calculate the length, you must convert it into meter in order to estimate the total tons of such reinforcement. So assume we have such table. So assume we have such table, we are going to prepare a bar bending schedule. So let me demonstrate one structural drawing in order to see what we are going to do on such. So I will minimize here. I'm going to open a folder here and other to explain much more. I'm going to locate one PDF. Yes. Okay, this is one of my recent project that we did. So this is columns. This is a general arrangement. So let us take assume a foundation that we are going to do the bar bending schedule. This is a general arrangement of the foundation. So let us come here. Assume we are going to take BTA, that is base schedule. We are going to work with BTA. We have the number of such BTA, which is 2. That is the size here, 1.95 plus 1 by 1.95 by 330 mm. So which is BTA here automatically. So when I come here, this is the BTA here, as you are seeing. I zoom it for you automatically in order to see. So in order to estimate the quantity of the reinforcement, it is when we check one of the bar here, which is this one that I am demonstrating. That is, it has, you must know even the shape, you must know how to read the shape such reinforcement. If I like all these reinforcement or all these yes, all these rebars in the footing, I can present it with only one shape in the bar bending schedule, unless if it does not have the same bar mark, the same length of bars, the same spacing, and so on. So if I check here, that is Y1601 at 250. When we say Y1601 at 250, that is the first location, bottom one. So if I check the other one, it is Y1203 at 250 center to center. It means the size of the reinforcement has changed, in which then the bar mark also will change. Since they don't have the same size, you cannot put the same bar mark for it. When you come back here, Y1204 at 250 center to center, top two, that is the location. That is the location of this one, and this one change. Then the bar mark also change. When we come back here, Y1602 at 250 center to center, bottom two, it means the location change here to bottom two, while here the location here, it is bottom one. So in order to estimate the quantity of the reinforcement here for just the pad base, this is the section of such pad base. When I come here, automatically what I am going to do is to know the total length from here to here, which is 1950. So let me bring my calculator into account in order to play some role here. When I click, I will open the calculator. What I am going to do, the total weight, which is 19550, 1950, then minus the concrete cover here at the left hand side, which is normally 50, minus the other concrete cover here, which is automatically 50, which will give us 1850. That is the total length at that position. And we know the thickness of such, it is 300. We are going to remove the concrete cover here and the concrete cover here. So what I am going to do, I will come back into my Microsoft Excel. That is, I will say the serial number one, the element, which element I'm going to do. I'm in footing, that is BTA, that is base type A. What is the bar mark of what I'm going to? That is the reinforcement, which is O1. I'm starting with O1. If you check, I'm going to start with O1 here. Then if I come, what is the size of the rebar? You will check the size of the rebar, which is Y16. Then I will come here and put 16. What is the quantity of the reinforcement at that position? So the quantity of the reinforcement, it is when you calculate normally the length from here. If you know the spacing, what is the total length from here? We remove the concrete cover here. We also remove the concrete cover here, which also give us 1850 divided by the spacing, which is 250. Then we will say plus 1, which is 8.4. We can approximate it to 8.4. We can approximate it to 9. Then we will come here and say that is 9. So what is the shape of the reinforcement? So in order to draw the shape of the reinforcement, I will use the normal laborious way that engineers are using in order to draw the shape of such reinforcement. When I check here, the shape of the reinforcement, which is this O1, I'm referring to this reinforcement. It is normally U-shape, which is going downward, which is just the orientation where we put the reinforcement in order not to bring too much complication. But here they have all the same shape, just some of them are facing right, some are facing left, some are in top, some are in bottom. So we can present it with normally the same at any way we draw it. So normally it is U shape. I can come into the tools of Excel. That is when I come here, I'll click on shape, I'll click on line. I can press my Alt button in order for it to be normally straight. I can come here and increase the thickness, carry another shape in order to increase the thickness, carry another one. So you see, like as I am drawing the bar shape here automatically, you see that I'm wasting too much of time in order to draw them. Click on this, click on the shape that I add, click here in order to group it before I bring it back here. So, and this one will take too much time for me. In order to reduce time, That's why we introduce this one. So when we look at the shape, here we know it is like someone can say U shape or C shape. It just depend on which one that you are going to say. But here it is shape code 21. When I click on shape code 21, I can click on any one of them. If I click, it will just create that bar shape for me automatically. I can click this one. I can drag it. I can bring it here automatically in order to place it. That is the shape of the reinforcement. If I like, I can work with this one. That is the level that we have into here. Then Control E here in order to put normally Control Z. Then delete this B in order to put the line that we estimate before in the calculator, in which is let me delete this one, which is 1950 minus 50 minus 50 also, which is 1850. I can put the 1850 here automatically. Then the other one that we estimate, that is the thickness of the footing, that we use the thickness of the footing, which is 300 minus the concrete cover 50 at the bottom minus another 50 at the top. It will give us 200 automatically. So I can come here and delete that C and put 200. I can come here also, they have the same height and put 200. I can enlarge this one. I can resize this one. I can take it here. I can take it here also. Then I can drag it inside. I can move this one also. Then extend this one also, and then put it here. So what is the weight of such a reinforcement? In order to calculate the weight of the reinforcement, in which it is the diameter squared all over 162, then we will say equals to this, then power 2 divided by 162, and it will calculate the weight of the reinforcement for us automatically. So if I am going to calculate the total length there, I will add this one, which is equals to, I will say 1850 plus 200 plus another 200. It will give us the total length of such reinforcement. If I am going to find the total length in meters, so what I am going to do, this total length times the quantity. The quantity here we have, it is 9. Then we will say equals to this multiplied by 9 and then divided by 1000. In which it will give us the total length in meters, which is 20.25. So when I come, this is the first serial number. Then we are not going to put another element. We are still in BTA. I will come into this bar mark. When I check, I open the software MATLAB. When I check the other one, we have a bar mark of O2, but it have all the same information with the other one. Then I have O2 here. Then I will click this one. I will drag it down. We have the same information. I will enlarge this one. I will make a copy, Control C, Control V. They have all the same thing. I will calculate the weight. I will drag here. The total length will give us like this. And then the total, also total length in meters will give us something like that. So when I come into the other bar mark, I'm going to go for O3 here, but the size of the reinforcement, it is what? 12. So what I am going to do, bar mark O3, size of the reinforcement, it is 12. Then the quantity also, it is the same thing, which is 9. Then I can come back here again, enlarge this one. I will say Control V, that is the total length automatically. Then here I will calculate the weight. In with the weight of Y12, it is different with the weight of such a Y system. And here the total length, I will do something like this, and the total weight, I will do something like this. Oh, okay. So when I come to the other bar shape, which is O4, that is the bar mark, it is O4. Then I will come back here also, the bar mark O4. I will put the diameter here. The quantity, we will also have the same 9. I will enlarge this one also. I will do Control V with the same thing, the same weight of reinforcement, the same total length, but here also the same thing that we have here. So when you have normally different shape of reinforcement, assume you are working on a column, you are going to use links let me enlarge this position. I'm going to use links. I will come back here. We have shape code 51. We have almost 8 type of links here. You can click on the first one. It will automatically put everything for you. Let me enlarge it. Then you will see the links here automatically, and you can drag it. Let me close this software. Let me come back here. Then you can enlarge it and also put the normally the length here. Edit this one, put the length here, edit this one and put the length here. So, but if you don't want to put normally the length into the shape of the reinforcement, you can add additional columns, in which I will do insert. I have 3 columns, in which the columns here will be A, this will be B, and this will be C. Automatically, I will just reduce the size here. In order to reduce the size here, it is 200. All of the A's are 200 automatically. Then this one also are 200 automatically. And this one also is 18550 automatically. I will just drag it here. Then this place, I will delete it and just leave the label as it is here. Here A, here B, here C. Sorry, here it is B, which is here it is A, and this is C automatically. But if I like, I can delete this one. I don't want it. I will just leave it the way I start doing it. But some might say when you are going to put the reinforcement, that is the one at the location 2, which is this one, you will remove the size of the reinforcement, which is at the bottom, in which we are using Y16, and then at the top also you will remove that size of the reinforcement, in which it is 16 also. Then this thickness here also will change automatically. Sorry, the length here will change automatically. Then we will have 200 minus 16 at the bottom, and also minus another 16 at the top, which will give us 168. Then you can come here, in which in this position you will change it, Control E 168, and also come back here, Control E 168, in order to represent everything here. Then to edit this one, 168, then plus another 168 automatically to calculate such. So I think with just this little demonstration, you got what you are going to do with the BBS version 2.0. With time, we will be creating lecture time to time in order to be demonstrating how we can use it. So this is just a little demonstration. Any shape of reinforcement that you have, assume we are going to shape code 11_5, you can click there. Then this is it has too much length. I can reduce the size, in which I will take it to any place I like when I'm going to put the shape of the reinforcement. Assume I'm going to use it here. I will delete this one. Then I will drag this one here. In order to fit it here, I will leave something like this, then and adjust this one like this. It will reduce much of my time in other when I'm doing the shape of the reinforcement. When I click on this shape code 63, you will notice the difference between the shape code 63 and the other shape codes of such reinforcement. This is the shape code 63. And then when you come back here, let me open another sheet in order to view everything. When I'm using this one, you will find it different with this one. And also when I click this one, you will find it different, all of this shape. This one, the anchorage of the hook, that is for the links, it is at the top, in which this one, it is at the bottom, and in which this one, it is inside. Normally, some of you knows these kind of links inside when you are dealing with site activities. And if you have a normally cycler column, we have it feature here in order to do such shapes for you automatically. But I am going to delete this one and then come back here automatically in order to view what I did before. So I think with this little demonstration, you have understand what our template will do. And also we will be creating lectures time to time. This is just a little introduction. we will fix another lecture in the next week in order to do another binding schedule of some element in order to see how we can use it. And normally this one we did not calculate normally the tons or the weights, such as simple calculations to do. So I saw a question here. Well done, engineer. You're doing well. God bless you. Thank you very much. So if there is any question, please you can unmute yourself